look a little bit different because that's what we are all about right now.
Okay, fine.
Okay. So the example I would like to start with is 3 to the x equals 21.
Nadia said her bus is late.
Okay, I did not count her absent, so I figured that's what it was.
What is it?
3 to the x equals 21. That is example A.
I don't know what
I
to
always
do
pull
with
out
that
first.
next variable.
Okay, is there anything I can do with it right now?
No.
Which means I probably need to change the form that I'm looking at it in. What do I know about every exponential equation? Can also be rewritten as a logarithmic equation. So then if I'm rewriting this as a logarithmic equation, what's going to be the base of my logarithm? And then I take the log of the answer to my exponential, which is 21. So I have log base 3 of 21 equals whatever my exponent was. So anytime we have an exponential equation with our variable in the exponent, I can rewrite that as a logarithmic equation, and then that exponent becomes the answer. So now I have log base 3 of 21 equals x, and we can solve that, can't we? What do we have in our arsenal that will help us do this? Change of base formula. So I can't just plug this into most calculators. There are some that you can. Most of our calculators only work in log base 10. So I use my change of base formula to solve this. Change of base says that I take the log of my larger number divided by the log of my base, and I just go ahead and put that into my calculator. So please do that and tell me what answer you get. Roughly 4 decimal places.
2.7712.
Correct. Approximately 2.7712. Make sure we can all plug that into our calculator and get that answer. If you don't have a calculator, there's a nice little set over here.
Nope.
Right. Any questions, concerns, or issues with that one? Anybody not able to get the answer when they plugged it into their calculator? We're all good. Okay, I will caution you that sometimes it's helpful to put parentheses around the numerator and the denominator anytime we're doing something with division. So if you are getting the wrong answer, it's probably how you're plugging it in. So it doesn't hurt to parenthesize each of these individually, okay? That's just really a good rule of thumb across the board whenever I'm doing division in a calculator. Next example, because I know we're so excited.
Yay.
Example B. 5 to the 2x plus 1 equals 6 to the x minus 2. Wow. I know, right? You don't like it? How can you not?
My brain isn't functioning. Oh my gosh, Miss Ren, it's so pretty.
Thank you, Becca. I'm glad you appreciate it like I do.
I like the colors.
So as I'm looking at this, my first thought is I can change this into a logarithmic problem, kind of, right? Is that our first hypothesis for how to solve this? Because that's what we did on the previous problem. However, it's not going to be as nice because I have 2 exponentials both with a variable in the exponent. Okay, so that's actually just going to make it harder to solve. So what I'm going to do instead is I'm going to try and break this down so it's all on one level. I know in all the information I've absorbed from this unit that if I had a log on both sides, that any exponent just comes out front, and then my entire problem is all at one level, and that makes it easier to solve. I don't have any logs in here, but I can put them in. So what I'm gonna do is I'm going to take the log of both sides of this problem, and then that's going to allow me to apply those logarithmic laws. So when I say take the log of, it's just like when we put a natural log in there, it doesn't multiply in. I'm literally taking the log of what I have on both sides of my equation. I do not have a base identified for these logs, so what do I assume they are? Base 10, yes. So now that I've taken the log of both sides, I can apply my logarithmic law that says any exponent can be brought in front of the log and multiplied in as a constant.
That's a rule?
We wrote them down.
That's like the C to the U.
Oh,
U to the C. Yeah, the C was just the exponent.
Oh my gosh.
So now I go ahead and do that. So when I do, I get my exponent 2x plus 1
I wonder if
times my log of 5 equals, I do the same thing on the right-hand side, so x minus 2 times my log of 6. So I just brought that exponent out front. I have to remember that that is all one quantity, so I need to keep it in parentheses. So we don't just think that we're multiplying the 1 into the log. No, it's the whole thing.
Wait, so the whole time I thought 5 and 6 were the bases.
If I didn't have an exponential on both sides, I could have rewritten it like that. But I didn't change this into a logarithmic form. I put a log on both sides so that I could rewrite the way it looks. So this is not changing it into a logarithmic problem like we were doing the conversions before,
How is it not if you're right?
because I had it on both sides and I didn't take this base as the base of my logarithm. I literally just took the common log of both sides. So as I'm looking at this, it doesn't look any better, right? So sometimes we have to make it worse before we can make it better.
That's a lifelong
So
story.
what do you think I'm gonna do to make it worse?
I won't say, but
How about I distribute the log into both terms inside each of my parentheses?
I mean, you can do whatever you want.
Could you? Because I right now have x's on both sides of my equal sign. So I need to not have x's on both sides of my equal sign. So I'm going to distribute the log into both items inside each of my parentheses. So when I do, I get 2x log of 5 plus 1 log of 5 equals x log of 6 minus 2 log of 6. Now that I have expanded this into 4 separate terms, I can take all of my terms that have an x and I can put them on one side of my equal sign. And I can take all of my terms that don't have an x and I can put them on the other side of my equal sign. So I'm going to go ahead and subtract over this x log 6, and I'm going to subtract to the right-hand side this log 5 plus u. So when I do that, I get 2x log 5 minus x log 6 equals negative 2 log 6 minus log 5. So I just moved stuff around so that all my terms that had an x were on the left, and all my terms that didn't were on the right.
wait, so since it's 2x plus 1, you just leave the right side of the left, like you just leave that log 5.
Yeah, because 1 times log 5 is just log 5.
Yeah,
So why would I possibly want to get all of my x terms on the left-hand side? I can take out the x, right? I can just factor it out of both of those or undistribute it, however you want to think about it. So when I do that, I get x times 2 log 5 minus log 6 equals, this whole right-hand side does not change. Now that I have, oh wait, parentheses. Now that I have the x outside of my parentheses on the left-hand side, what am I going to do with that parentheses? Divide it for both sides. So when I do, I get x equals negative 2 log of 6 minus log of 5 over 2 log of 5 minus log of 6.
Okay, hang on.
Yeah, I'm pausing.
Because I'm just writing it down, I'm not really comprehending.
Uh-huh.
But
We are not done because this is not simplified yet. I expanded it and got the x by itself, but now I can condense that numerator and that denominator because I have subtraction, which I know correlates to division, and I have subtraction, which again I know correlates to division. It's perfect. So what I want to do next is I want to take any number that's in front of my log and move it into the exponent spot where it should be. So when I rewrite this, well, actually, first I'm going to pull out the negative from both of these top terms because that's going to make it easier for me. So I'm going to have the negative of log of 6 squared plus log of 5. In my denominator, they're not both negative, so I can't do that. So I'm just going to rewrite it with the exponents. So then this one becomes log of 5 squared minus log of 6. I know that addition is going to change into multiplication, and then the subtraction is going to change into division. So then x becomes negative log of 36 times 5 over log of 5 squared is 25 divided by 6. And then I can go ahead and put that in my calculator.
okay. Wait, so what did you do before? You had it's above this.
This one?
No, above
Oh.
that.
Before that, okay.
I think it's in or green to red or
Green to red.
or
So I just took
maybe
the x
above that.
out of both of these terms and put it out front and rewrote these two terms without the x.
Okay, it might have been one above that.
Okay.
Wait, so did you just bring the, because we had like 5s on one side.
Mhm. Right, so I
you
moved
switched
stuff
them?
around so that this x term was on this side with this other x term, and this non-x term was on that side with the other non-x term, and then moved from there. Okay, what answer did we get? Approximately.
Negative 3.6389 or 8.
Who else got that? Show of hands. I want to see everybody be confident in their answers. Did anybody not get that? Okay, so I'm going to say that's approximately negative, what, 3.64?
How come you get to do that and we don't?
Because I'm the teacher.
You
Sounds
cheater.
like-
I don't get to use that very often, so I used it now.
Cheater.
I know.
Cheater.
Wait, what was the answer?
Approximately negative 3.64. Questions, concerns, or issues with this problem? It was long, but do the steps kind of make sense and how they work together? Okay. For the most part, if I give you a problem like this on the final, it's going to be one of those identify any mistakes if there are any.
Oh.
Are you kidding? I'd rather do the problem.
I'll keep that in mind.
No, you would not.
Okay,
You would not.
example C, and then we're halfway through the notes.
Hey,
Whoa. You have to find the smallest thing.
I love math. Hey, I like math, not this. This is not math.
That's pretty sure it is. Oh.
This is not math.
Oh, I think it is.
Oh, and I wrote 3.
What's going on?
It's math.
Third example, 5 to the x minus 5 to the negative x all over 2 equals 3. This is so much fun.
Multiply the 2, I guess.
Oh, yes. Okay, so why would I multiply the 2 first?
It's the easiest thing on
To get it all to one level. And it's the easiest thing on there. It's the first thing I don't like. Okay, so I multiply the 2 across to the right-hand side.
No, it's definitely.
And I
not
get
the
5
first
to
thing.
the x minus 5 to the negative x equals 3 times 2, which is 6.
It's definitely the only thing I know.
Okay.
Take the factor 5 out.
What?
What?
Can you move the things down? No.
What things?
Never mind.
What do we notice about the exponents present on that left-hand side?
Cancel
Yeah,
it.
negative
They
exponent.
They do not cancel each other out. Good try, though.
I wish.
If I were multiplying them, they would, but not adding them or subtracting them. One of them is negative, right? And what do I know about a negative exponent? It moves to the opposite side of the fraction. So this is the same as 5 to the x minus 1 over 5 to the x equals 6.
We just got rid of the fraction. Yeah, that's this is ridiculous.
We will in a second.
Ooh, this is actually not too bad.
Remember you said that. Okay, so what do I not like about my problem now? I have a fraction with a known denominator. So how do I get rid of a fraction with a known denominator? I multiply that denominator into all of my terms. All of them. So when I do that, I get 5 to the x times 5 to the x minus 1 over 5 to the x times 5 to the x equals 6 times 5 to the x. By doing this, the fraction cancels out, and I'm left with 5 to the x squared minus 1 equals 6 times 5 to the x, yes.
Why is it not 25 x?
What do you think?
It doesn't want to be.
I'm not saying that it's not. I'm telling you that we don't want it to be that way right now. Because I'm going to show you something.
Oh, it's gonna be cool.
Say that again, honey. What were you thinking? Yeah.
Well, then the x and the x squared.
Well, it would add together and it become 2x technically. But we want it to stay like this for a minute. Okay?
Make it hard.
Yep.
That's why.
So now what I'm going to do is I'm going to move everything around so it's all on that left-hand side because I hope that you're going to see something.
I see a lot of.
Oh, who said it?
I did.
It's a quadratic. I have 5 to the x squared minus 6 times 5 to the x minus 1 equals 0. I have 3 terms. The first term is the same variable as my middle term, but it's twice that, or squared, which means that this is now a quadratic. I know it's hard to see, so we can use u substitution to make it a little bit easier. So temporarily, I'm going to replace the 5x with a u, which allows me to look at this as u squared minus 6u minus 1 equals 0. And now it's clearly a quadratic. And what can I do to solve a quadratic? Quadratic formula. Right? Didn't think you'd be using that today. So I do my quadratic formula and I get 6 plus or minus the square root of 36 minus 4 times a times c all over 2 times a. We go ahead and simplify this. 36 minus 4 times 1 times negative 1 becomes 36 plus 4, which makes it 40. All over 2. Of course, I can take a perfect square out of 40. Which one? 4. And what's the square root of 4?
2.
And then what's left when I divide 4 out of 40? 10. So square root of 40 becomes 2 root 10. So now I have 6 plus or minus 2 times the square root of 10 over 2. Now what do I notice? I can take a 2 out of all of that. So I get u equals 3 plus or minus the square root of 10. But did I originally have a u in there?
No.
What was it originally? So I actually have 5 to the x equals 3 plus or minus the square root of 10. And I can rewrite that as what to solve for x? What can I rewrite any exponential function as when it looks like this? A log. So now this is the same as log base 5 of 3 plus and minus the square root of 10 equals x.
Oh.
So I actually have 2 problems here that I'm testing. I'm testing 3 plus root 10, and I'm testing 3 minus root 10. Are both of those guaranteed to be answers? No, why not? I cannot have a negative inside of a logarithm. So are either of those going to give me a negative answer? 3 minus the square root of 10 is going to give me a negative because the square root of 10 is 3 point something.
Yeah.
So I can't take 3 minus root 10. I'm only going to be taking 3 plus root 10. And then I can just plug that into my calculator using my change of base formula. So then this becomes log of 3 plus the square root of 10 over log of 5. And I want you to plug that into your calculator and get an answer.
Wait, so why, okay, why should put the 5 on the bottom, log 5 on the bottom?
Because that's the base of my logarithm, and when we do the change of base formula, we always do log of this over log of that. That's our change of base formula. That didn't change anything. Okay. When you have an answer that you are confident with, please share it with the person sitting next to you.
What is that hitting in your hand?
My brain, sorry.
I was so confused. It's like you're like marble.
I carry marbles around in my hand, you know? Why? Why would I do that?
You never know.
Jackie, what'd you get?
Yeah, I did. 1.1299.
Correct. We get approximately 1.1299 as our x value. Is there a way to check that that's going to work? Plug it back into the original problem.
We're not doing that.
We won't, but you are welcome to if you so choose. Are we ready for our last 3 examples?
Wait a second.
Wait,
I just took up a whole page.
I'm not coming
I
out.
might
with my
have-
answer.
I might have a.
We're gonna write.
I have
smaller.
paper back there.
I mean, I have a full notebook here.
Oh, okay.
But what I'm saying is,
I got mine.
What did you do?
Just going
all the way over.
Like,
what the frick? Okay. I don't know what's up with
Do you think I'll have enough room for this whole piece of paper? Or should I start?
You might, depending how big you make it.
I don't write that big.
Okay, so you might. We'll say you will.
I bet.
Example D. Log of the cube root of x minus the square root of log of x.
You're equals.
I meant equals. It's equals, not minus. Sorry. Okay, are we ready? I will say that I think this one takes, for the most part, less space than the previous problem.
That's reassuring.
The first thing I want to do is I would like to rewrite my radicals as exponents when I can. Okay, so on the left-hand side I can because I'm just taking the cube root of x. So what is the exponent that's equivalent to cube root? 1/3. So this is the same as log of x to the 1/3 power. Can I do that same thing on the right-hand side? No. Technically no, because I'm taking the square root of the entire log, not just the variable.
Can't put 1/2.
You can put parentheses in 1/2, but I think that's just going to confuse you, so I'm going to leave it as the square root of log, because that's not going to be able to drop out front. What do I do once I have an exponent written on my logarithm? Move it out front, because that just makes it easier to work with. So this is really as far as I can go, knowing that my right-hand side is still under the radical. If possible, I'd like to change that.
Square it.
Square
All sides.
both sides. When I square the right, the square and the square root cancel each other out, and it's just going to leave log of x. When I square the left, I'm squaring both the 1/3 and the log of x, that entire thing. So this becomes 1/9, parentheses, log of x squared, equals, and then just log of x.
These parentheses are getting. How do you?
Right now I have a fraction out front, and I think that's really gonna mess with me. So how could I get rid of that fraction out front? Multiply both sides by 9. When I do that, I get log of x squared equals 9 times log of x, right? I just multiplied it over to that right-hand side. So in theory, if I didn't have a squared here, I'd be able to cancel and just solve. But since I have that square there, it doesn't work that way. So what I want to try to do now is use some of my algebraic knowledge. That if I want to solve this, sometimes it's easier to get everything on one side of my equal sign and see if I can pull out a common factor. So I'm going to go ahead and subtract that 9 log x over, which will leave me with log of x squared minus 9 log of x equals 0. Here I have two terms. I have log of x squared, which is the same thing as log of x times log of x. And then I have negative 9 log of x.
Oh, no.
What do they both have in common?
Log of x.
A log of x. So I'm going to take that out and put it out front. So when I do, I'm left with
Make us complete the square.
log of x times the quantity log of x minus 9 equals 0. Are we all okay there?
No, it's rough.
Got it all on one side, took out a common factor. Just so happens that my common factor here was the function log of x, which is fine. That happens.
You did that on purpose.
Maybe I did. So as I'm looking at this, this is the same thing as log of x times log of x minus 9. If a product is set equal to 0, then these are its factors. And if I want to solve, what can I do with those factors? Set them equal to 0 and solve. So now I'm going to have log of x equals 0, and I'm going to have log of x minus 9 equals 0. Of course, it's kind of difficult to solve them the way they are right now. So I'm going to go ahead and change each side into an exponential function. So whenever I have log of x with no base, what do I assume the base is?
10.
So this is the same as 10 to the 0 equals x. What's 10 to the 0? 1. Anything to the 0 power is 1. So for my answer on this leftmost function, I get x equals 1. I'm kind of going to do the same thing on that right-hand side, except first I have to add the 9 over. So I'm going to have log of x equals 9. From here, I'm going to go ahead and rewrite this as an exponential function. We assume my base is 10. So I get 10 to the 9th equals x. That's going to be an extremely large number. It's a billion. It is. Because 6 zeros is a million, another 3 makes billion. I'm not going to make you write 1 billion. You can leave it as 10 to the 9th for this. So then what are my two answers? 1 and 10 to the 9th. Do I just blindly assume that those are both my answers?
Yes.
What do I have to do?
There's no negatives.
I have to go back to my original function and make sure that when I plug either of those in, I still get a positive inside of my logarithm. Really, the only one I have to worry about is this one. So the cube root of a positive is still positive, so I'm good. That satisfies it for me. Both of these work. And of course, since they are solutions to an equation, we would put them in curly brackets. Questions, concerns, or issues with that one? How did we feel about it?
I'm gonna get the entire homework.
Don't say that. I only gave you 5 problems for today's homework.
Let's go.
So not super bad.
Today, I have never related more to Gabe in my life. Just the fact that he's been so wrong today is so funny.
Yeah.
No offense, Gabe.
No offense.
Example E. So this one's a story problem. I'm going to read it, and then we're going to pull out the important information, okay?
I think I definitely have another room.
How is it possible to get a support problem?
Well, it's more contextual information. Okay, so it says the Baeyer-Lambert law states that the amount of light, I, that penetrates to a depth of x meters in an ocean is given by the equation I equals I naught times c to the x power where C is between 0 and 1. So it's a positive base that's less than 1 but greater than 0. And I naught, which is the IO right there, is the amount of light at the surface. So I'm just going to identify that information. So I naught is the amount of light at the surface. C is between 0 and 1. And then I is the amount of light at depth x. So there are two parts to this problem. The first one asks me to solve for x in terms of common logs. So I know I'm going to have logarithms in here somewhere, but they're not going to be the natural logs. They're going to be the normal logs. Okay? So that's going to be part A. So I'm going to rewrite my equation, and then we're going to start manipulating. If I equals I naught times c to the x power, and I want to get x by itself, what's the first thing I'm going to have to move? The I naught, or the IO, whatever you want to call it. Currently, that's attached to my c by multiplication, so what's the opposite of multiplication? So I'm going to divide it out from both sides. When I do, I get I over I naught equals c to the x power. Uh-oh. What am I going to do now? Log time? Think so?
Yes.
Okay, what do you mean by log? I am, because it's an exponential function right now. I have a base to an exponent equals an answer. So that means I can rewrite this as a logarithmic problem. My log then will have the base of my exponent, which is c, to the power of I, or not to the power of, sorry, log of I over I naught. And then that's going to equal my variable x. We solved for x, but that doesn't mean that this equation is ready to be plugged into a calculator. So we have solved for x, but how could I rewrite it so it's calculator friendly? And by that you mean the change of base formula, right? So that means this can also be written as log of the I over IO over log of C. And then that would be it.
Problems like this are usually
I do have algebra 2 next. I should leave it up for honors algebra 2 because they're going to walk in and they're going to walk right back out.
Okay, kids, here's what we're doing today in class.
Especially since we just did like rational root theorem for polynomials.
I don't remember what that is.
Factors of the constant over factors of the leading coefficient. And then we take all those numbers, we plug them into synthetic division to try and find the ones that work. Hopefully that's ringing a bell somewhere. Okay.
For anything else.
I have no idea. Okay, so that was part A. We do have a part B here as well. And part B says that if C is the value 1 over 4, approximate the depth. So that's our x. Where I equals 0.01 I naught. Good one. Good one. Okay. So the good news is we've already done all the hard work. Right? We can just take this information now and plug it into this equation that we found in part A. So I'm going to rewrite the equation, obviously, and then we'll go from there. So my equation is x equals log of I over I naught all over log of C. So it told me in this specific problem that C is going to be what value? So I go ahead and I put that in there. I'm going to put it in as a decimal though because that's going to be easier for me. So 1/4 is the same as 0.25. And then did I know anything about I or I not? I is equal to 0.01 I naught. So I'm going to replace that I with 0.01 I naught. So now I have log of 0.01 I naught over I naught all over log of 1/4. Can I simplify that log of 0.01 I naught over I naught? The I naughts cancel. So I'm just left with log of 0.01 divided by log of 0.25. And guess what? I can put that in my calculator. Right? It's magical. I'm faking it. Faking it, but it's okay.
Love that. At least you have
3.
Just 3.
Yeah.
Just 3.
0.32. 199.
There you go.
What?
3.3219.
There it goes again.
This is just a rough day for Gabe.
No,
Man.
I got 3 again.
He sounds like the rest of us.
I'll look in a minute. Nicole will figure it out. If not, I'll look at it in a second. Okay, so we have one more example and then we're done. I think we might have time to. So clear the RAM, it could just be a function. I'll do it in a second. I'll do it in a second.
She knows that her part of the calculator. I don't even know it.
Okay,
Wait,
so
hey, how many have space?
Is this the last one?
Is this the last one?
this is the last one. Is it long?
Yeah, it's probably gonna take up at least half page.
It's a story problem. So really the work is just this.
Oh,
Nothing crazy. Okay,
okay.
ready for the story problem? It also applies kind of to that previous problem, but we're gonna use a different equation. So if a beam of light that has intensity I naught is projected vertically downward into water, then its intensity I of x at the depth of x meters is the function I of x equals I naught times e to the negative 1.4x. It wants to know at what depth is the intensity 1/2 of its value at the surface. We're assuming that at the surface, trying to make sure I heard this right. Yeah. Okay, so x equals 0 is at the surface. So that means that if I have intensity at the surface, that's I naught e to the 0, which is just going to equal I naught. So that means this is just proving that my initial intensity is I naught at the surface of the water. Okay, so what we want to do is I would like to find the depth or the x where the intensity is 1/2 of its value at the surface. So I of x at depth x equals 1/2 of its intensity at the surface. What was the surface intensity of my water? I naught. So if I want 1/2 of that, that's just 1/2 I naught. I'll look it up. So my goal is to find the x where I of x equals 1/2 I naught. So of course we're gonna take this 1/2 I naught and put it where the I of x is in that equation. I'm gonna rewrite it since I moved it up. My initial equation was I of x equals I naught e to the negative 1.4x. I'm trying to find where my intensity is half of what it was at the surface. So I'm going to take this 1/2 I naught and substitute it in for the I of x. So I have 1/2 I naught equals I naught e to the negative 1.4x. I'm waiting.
You only took the 1/2 and
I took the 1/2 I naught and replaced the I of x with that. Because my goal is to find where the intensity is half of what it was at the surface of the water.
because I thought you were taking that and putting it inside of the x.
No, because I'm trying to find the x, so I don't want to plug anything in for that. So now I'm just solving for x, right? What's the first thing I want to move?
I know.
The I naught. I want to divide that sucker out from both sides. When I do, I know it's going to cancel on the right. What happens on the left? Isn't it going to cancel and just have a 1/2 left? I meant on the left. I don't know if I said left or not. Because I naught divided by I naught cancels, leaving just the number that was attached to my original I naught. So then this becomes 1/2 equals e to the negative 1.4x. Say that again, but louder.
A stick.
The natural log is the only way to cancel out that base of e to bring my exponent down to the main level. What I do to one side, I also have to do to the other. So I'm going to take the natural log of both sides of my equation. I recognize that the natural log and the e cancel, leaving me with the natural log of 1/2 equals negative 1.4x. And then to get x by itself, what do I do?
Divide by negative 1.4.
Divide by negative 1.4. So I get x equals the natural log of 1/2 divided by negative 1.4, and I can put that into my calculator.
Why isn't the natural log of that divided by?
Say that one more time.
Why is it the negative 1.4 in the parentheses of the log? Why is it underneath?
Because it wasn't part of the left-hand side when I took the natural log of the left-hand side. And on the right, the natural log and the e canceled, so I didn't actually take the natural log of anything in the exponent. Everyone okay with that?
I guess.
So then, what's my answer?
0.4951.
0.4951. Approximately. How do we feel about that?
Terrible.
Terrible, awful, awesome?
I guess.
Okay, homework is 5 questions. It is on Canvas already, so if you have questions, obviously let me know. And then tomorrow we just start some basic fun review. It's gonna be a blast. I'm glad you think so.
I don't have enough information.